Hello Year 12, thank you everybody who's sent your test papers in so far. I will send the mark scheme out tomorrow, that's Thursday. I've had a look through it, I've had a look, and there are a few things I think I need to go through depending on who sent the test paper in. Okay, so let's get started. There are, as I say, there are always certain things you have to remember in physics off by heart. As you not strictly have to remember, but if you remember them, it makes life so much easier. In this topic, of course, you've got to know that work equals force times displacement, or force times distance. Also, in all science lessons, you need to know that power equals energy per time, or energy equals power times time. You also need to know that efficiency is useful energy out over total energy in. That's also applicable for power. It can be power output over power input. Okay, power output over power input is the same. Power out, useful power out over power in. Okay, so we've got those things, and those are the things you need to remember. There is another thing that I think is useful if we combine these two together. So remember, work is force times distance, and power and energy is power per time. Sorry, is it power times time? If we look at this, okay, so if we say work equals force times distance, and we want to change that into power, we divide both sides by time. Okay, so in other words, power, which is on this side, equals force times distance per second. Another way of putting that is force times velocity. Power equals force times velocity. That you need to remember. Okay, force times velocity will give you the power. Force in newtons, velocity in meters per second will give you the power. Okay, so before we start anything, we need to know those. There is another equation which I think you all know already. F equals ma. All right. Pause the video and write down these, the ones I'm putting a square around. Pause the video now, write those down, make sure you remember them off by heart. Oh, and this one. I think you will remember most of them. Pause it now and make sure you can remember those before we go through the test. Okay, so pause it now. Okay, hopefully you've got those. All right, they're all done nicely. Now, let's go through these questions one at a time. Okay, so the first one, question one, and we're not going to do all of them, but I think this question one is worth looking at. Right, so we've got different options for the unit of power. Okay, so the first one is, well, that's work per second, which is Newton meters per second. Force times distance divided by time. Okay, so that is a unit of power for A. For B, this one is kilogram meters squared per second cubed. All right. Now for this one, I think this is quite a hard question. I started looking at newtons per meter for gravity and various things, but I think the best way really, after a bit of thinking, is to use this equation that we've seen earlier, F equals ma. Now, if we look at the equation, of course, that means newtons equals kilograms times meters per second squared. So we can rearrange that. We can rearrange newtons and units, just like an equation. Okay, so we can rearrange that. So how are we going to do that? Let's have a look. F equals ma. So m equals F over A. Therefore, kilograms equals newtons per meter per second squared. Okay, running out of space. And so if we rearrange that, we end up with newtons second squared divided by meters. Okay, so that now can replace the kilograms. Let's see what happens then. So we've got Newton second squared meters squared over seconds cubed times meters. All right, let's cancel all those things out. So we can cancel the m's. Okay, and we're left with m on the top line. We can cancel the s squared. That comes down to s. So what are we left with? We're left with Newton meters per second. In other words, a Newton meter, remember, is work. Work is newtons times meters per second. So that is, yes, work per second is power. Energy per second is power. That's work per second. Okay, we could write it like, well, once again, it's force times power. You could say force times power, or we could say it's work divided by time. C now, what was C? C was just joules per second. Well, I hope we know that's power, yeah, because that's here, isn't it? It's here, energy per second. Where's it gone? Energy per second. Okay, so we should know that one. And then D is the only one, if you fiddle about with it for long enough, it will not equate to joules per second, to power. So this is the one, so that one's okay. This is the one that is not a unit of power. That's question 1. Going on to question 2 now. Okay, question 2, that first one was the hardest, but at question 2, we'll just look at question 2. Okay, so work, well, yeah, we just use that. Work equals Fs, force times displacement, and work equals force, equals, so we can change that to work equals force times velocity times time, because displacement equals velocity times time. We're just replacing displacement. Remember, velocity is displacement per second, so therefore displacement is velocity times time. Okay, and then we just put the numbers in. Well, we have to do something first. What do we have to do to that first? You can do that yourselves, can't you? What's wrong with that? We can't put that number in as it is. All right, I'll say no more on that. You can work that out. Number 3. Okay, so remember, when there's a collision or an explosion, as long as there are no external forces, okay, momentum does not change, or it's conserved, as we like to say in the jam making industry. Momentum is conserved, okay? Kinetic energy, is kinetic energy conserved? Well, no, it's not, is it? Because they weren't moving in the explosion, and then they were moving after the explosion, so that kinetic energy has come from somewhere. It's suddenly increased. And same with a collision. Remember that when things collide, kinetic energy usually is not conserved unless it's a perfectly elastic collision. Okay, going on to question 4. Question 4. Okay, what have we got with question 4? Yes, okay, that's the same thing really. So we need to know, remember that formula again, efficiency equals useful energy out over total energy in, and that can relate to power as well as energy. So it can be useful power out divided by total power in, okay? All right, so the input power in equals 100 watts, power out, output power, don't know why I've used different notation, equals work per second, okay? And work is equal to force times displacement, and that's time there, okay? So we've got FV, which equals 100 times 0.5. Okay, we'll leave that there. I hope that's helped a little bit with the first ones. Okay. Remember though, PS, send your scores in. Send your scores in to me. And are there any other questions which you had quite a bit of difficulty with and you're not sure about, just send me the question number and I can do a video to explain those. Thank you. Sorry it was a bit long.